All right, thank you, Jonathan. Thank you, SPC, for hosting us. My name is Wei. I'm the co-founder and CEO of UCR. We are building rugged humanoid robot for dangerous tasks. There are a lot of robotics companies trying to build a future where billions of general-purpose robots work for us, making physical labor optional. That is a great future. That is a future we are also building. Just like every robotics company, we also started with the dull jobs in warehouses and factories. I actually work at a warehouse, and I learned that a lot of tasks in warehouse requires fine and dexterous manipulation, a technology that still takes decades to mature, but the robot has to compete with low-wage worker, like this guy. Well, we think if you have billions of dollars, starting with a warehouse and assembly line is a good idea. But now, we have a great idea. We are starting with a dangerous task in construction, mining, oil and gas, where a lot of tasks can be done by simple gross manipulation, like picking up rocks, pressing a button, turning a valve. But we do need a very good mobility to navigate through the rugged environments, including stairs, unstable and uneven surfaces, and messy floors. If we can build that mobility, we can go to market much faster, and we can create huge amount of value. That is a great way to the future we are all waiting for. So that is also why we are building general purpose mobility with leg system. As a company, we believe in building in public, and we believe in moving fast. So we're going to show you what we have built in 4 months with 400K, introducing Mobi. This is our test bed to develop general purpose mobility. So Mobi is actually blind right now. It doesn't see anything, and it looks a little bit drunk. That's because everything is driven by one single external sensor. That is a consumer-grade IMU under the pelvis. Half of our team are from autonomous driving industry, where we use sensors that cost millions of dollars. But today, thanks to machine learning, we can achieve very good performance with low-cost sensors. When the robot is working, it needs very good traction and reduced ground impact. Normally, that's a very hard engineering problem, but we want to find a solution that's available and low cost. So Chris and Wenlong went to Ross, dressed for less, bought a nice-looking pair of sneakers, $20, problem solved. The robot is driven by end-to-end machine learning model we trained. Wenda built an efficient training pipeline where we can train 10,000 robots at the same time in simulation, gaining millions of hours experience overnight. A lot of our friends in the same industry think end-to-end machine model can solve everything, but we think classical physics-based method has a lot to offer. So that's why we fuse these two methods, and we can iterate super fast. We can train and deploy one model every day, and that is just a start. I want to thank SPC for the opportunity to give us take time to go from -1 to 0, to go from good to great. And I want to thank Soso from 43.io give us the opportunity and take a risk with us. And finally, I'm super proud to be with my awesome co-founders here. So Chris. Chris is a legend in humanoid robotics industry. He was the chief engineer who built NASA's Valkyrie humanoid robot. Wenlong, another legend in humanoid robotics. He built the world's first running humanoid. That's a critical milestone in the history of humanoid robotics industry. Wenda used to be a staff machine learning engineer from Apple's Special Project Group. He led the perception system for Apple's autonomous system. I almost said something I shouldn't say. All right. Thanks, everyone, and happy to take any questions. Come on stage.
how would you differentiate what you're building or the path that you're on from what other robotics companies like Boston Dynamics building a humanoid robot that can walk over rough terrain? What's your differentiation there?
That's a good question. So our fundamental difference is that we are going to the dangerous task instead of a warehouse and assembly line. So that's most other companies are going after. We see huge
Why
value.
wouldn't Boston Dynamics do a dangerous task thing also?
To be honest, I have no idea. Do you want to add anything?
Sure. Many of the environments, you need custom-built hardware, for example, explosion-proof or intrinsically safe hardware that you just wouldn't get or you wouldn't do if you were looking at warehouse robotics. So being designed specifically for that environment, we think is a major a moat that we can leverage in the future.
Cool. Thanks.
Awesome, thank you. Thank you. Great demo and great achievement for sure. So you started with manipulation, saying with manipulation, and then you ended with bipedal walking. I'm just curious, all right, why this twist, or why you started with bipedal walking?
So first of all, most of the robotics company, they skip leg day. We don't skip leg day. So, and it's also a choice we make. We think to generate actual value with the dexterous manipulation is going to take a while for technology to mature. But we think it's closer that we can deliver a general purpose mobility with a very simple gross manipulation. And we see a lot of value can be created with this combination of these two technology. And that's why we are going after this.
Question back here.
Just to add, we think gross manipulation is really close to being a solved problem. I've built tons of robotic arms and tons of end effectors. Like we can build the rugged system that can do the gross manipulation without having to worry about and investing billions of dollars into something that can compete with each and every one of us has at the end of our arms.
Question back here.
Just help me understand the frequency of use here, because when you think about the original use case you're not doing, which is day-to-day warehouse work, but dangerous tasks, how often will that happen in a day for your target customer, and maybe like clarify that target customer? And what's it going to take to go to market? You said it took $400K to get to this awesome prototype, but how do you get to market? What's that going to look like cost-wise?
Sorry, what was your first question?
Just help me understand the use case when it comes to dangerous tasks. Is the frequency of use in a day, like is a dangerous task happening just once a day? And so is a customer willing to buy something that will only be used a few times a day, or are dangerous tasks happening all the time?
So that is actually a very great question because that comes down to a comparison people always make, like why do we build a humanoid versus purpose-built robot? It's really about the frequency of the task. So a lot of the tasks are very diverse and only happen very low frequency. So if you have a purpose-built robot for each single task, that's economically that doesn't make sense. But you have one robot that can do a little bit of a lot of tasks. That's the value we see we can create for a customer. And in terms of the cost, so a lot of the dangerous tasks are very high-value tasks because they need to send human into a dangerous environment. That involves a lot of logistical costs, like you have to hire first responders to stand by, and you need to send human into the environment. And to prepare human to enter that environment, you have to stop the production. That's a lot of revenue loss. So we think if we can solve the problem for dangerous tasks, we can create a lot of value beyond replacing the worker, but a lot of costs on top of the labor cost. Do you want to add anything?
That was great.
Okay. Okay, cool.
I'm going to add one more thing in the same flavor of what we discussed with Deep Cogito earlier. I think that what we're really seeing is again, the normal message out there is like, hey, I mean, look at robotics companies right now, especially the general purpose humanoid robotics companies. They've raised, hundreds of millions of dollars, like if not close to billions of dollars, in terms of like building out these general purpose foundation models to enable essentially mobility and dexterity. But I think what you're really seeing is that there's a ton of things that are really interesting if you're willing to, number one, constrain domains, but then also relax some constraints. And there's a lot more possible with smaller amounts of capital that can go a long way. And I think this is the first time you're able to peek into that frontier relative to over the last few years. So I think super stoked to be working with these guys. I think it's super interesting what they're working on. And congrats on a good demo. You pulled it off.